Hello and welcome to our third edition, I think, of OperatorCon. I hope it's the last one we are doing virtual. And next time we really can meet in person. I'm really looking forward to it. We had before a conversation already, like somehow real conference feeling is not coming up in this virtual conferences, and I'm really curious to see you all again and exchange about ideas and also talk about new technologies. But unfortunately, this time virtual. So today, really looking forward to have three interesting talks about Kubernetes Operator. I think we started this conference with the intention that we saw operators becoming more and more important to run workload on Kubernetes. And during the times, the last year and before, we see really the adoption of Kubernetes Operator. But on the other side, we also see Kubernetes operators is nothing easy to build. What we are doing here at Kubernetes, it's all-time hard to, we do it all day long and we have a lot of experience, but we see it also with a lot of customers that they are have challenges or at the beginning on how to build operators, really looking into using this in their production. And but I hope also with this OperatorCon we can bring in some thoughts how others are using it, how they're building it, and what are the benefits of using operators in your daily operations. And so I think especially this reconciling of Kubernetes operator is a really strong and powerful way how you can automate your daily operations and can scale over software. And from my side, I'm really looking for the different talks, seeing what ideas other companies have, what ideas, how they're using the operators, but also understand what are the challenges they're facing with this approach, and hope we can all learn from this and understand how this goes and what are the future of Kubernetes operators in the next years. And with this, handing over to Caro to introduce or to give you some more background about how this today works, and also starting then with our first session.
Yeah, thank you, Sebastian, for the intro, and hello everyone, and also warm welcome from my side to our second OperatorCon. So Sebastian, I need to correct you, it's the second edition and not the third one. Some of you might have already joined us maybe in our OperatorCon last year in November. We were really overwhelmed by the lively participation we generated. And what we've seen so far, as Sebastian also has already mentioned, is that Kubernetes operators is an important topic which is attracting attention and awakening a lot of interest. And that's why we decided to bring cloud native experts and the community together again today. And yeah, that's why we are here today. I'm very happy to have really three excellent speakers on our virtual stage today. So Jochen Mader from Instana, Philip Krenn from Elastic, and a colleague of mine, Sasha, from Kubernetes. They all have gained quite a lot of experience in the field of Kubernetes operators throughout the past few years, and they are more than excited to share this experience today with you. But before we can jump into the exciting part of this conference, just some very organizational information. I guess, by now we're all like Zoom experts, so I don't think there's like a detailed explanation required of how this works. But for your questions, please use the Q&A chat window below. There will be like a very short Q&A session after each talk. We have 5 minutes before the next talk starts. Just in case that we run out of time and we still have too many questions left that haven't been answered yet, please don't hesitate to reach out to marketing@kubernetes.com or to reach out directly to the speakers to go through your open questions with them. What else? We are recording this session, so in case you need to drop out earlier, or for all the attendees who will maybe join us later on, and maybe missed some parts of the conference, that is no problem at all. So we will send out the replay in the coming days. We will upload it to our YouTube channel. You will find it on our Kubernetes and on the OperatorCon website. So there are really a bunch of ways of how you can get this recording. Yeah, but that's it with the marketing stuff for now. So let's get started with the first talk by Jochen Mader. Jochen is a principal systems engineer at Instana, and he will talk today about distributing Instana to customer-maintained Kubernetes clusters. But I don't want to anticipate too much because I'm pretty sure Jochen will introduce himself and tell you more about his journey so far. So welcome, Jochen. The stage is yours now.
Thanks a lot, and thanks for the introduction. So first task, sharing the correct screen. So, oops. Where is it? Yeah, here we go again. Oh, now I got it. So first of all, I'm very sorry for this title. I messed up ending in like a better one. Like I was planning about having like something more manageable, but this contraption that came out, like that's completely my fault. I promise to have a better title next time. But like it's basically the illustration of things that I'm going to talk about today. This talk is trying to sum up 3 years of hard work in 30 minutes. So it's going to be a pretty rough ride for you all. So first about me, my name is Jochen. I'm a principal systems engineer at Instana, recently acquired by IBM. I switched to Instana around, I think, 3.5 years ago, after a long times in consulting and a couple of other startups before. And I would like to get started with a little history that we went through, because like it's rather interesting where we are today with Kubernetes, considering like where we came from. I guess a few of you already like know or remember the world of pain that we went through like initially. And this is basically like the first time I really got into workload management, which with Hadoop Yarn, which was pretty much like one of the most painful experiences I've had in my life. From Hadoop Yarn, I was fortunate enough to move like to the next fast data project, which opened a whole new world for me, like for the first time seeing like how workload management could be something that's actually enjoyable to work with. There was a time when we got like the first projects with Apache Mesos and Marathon, for those who know these. It was interesting to see like the flexibility that could actually be gained from it. It was still a rather complex situation we ended up in. And this led to like what I then saw after dropping out of the fast data world into the product world at Instana, was that for the first time I really saw like how workload management could be convenient. Not yet Kubernetes, that was Nomad. And this is basically where we started a few years ago. So like our whole original cloud infrastructure at Instana was running on Nomad for quite a few years. And we finally migrated off Nomad, I think 1.5 or 2 years ago. Since then, everything we do in Instana, like moving around petabytes of data, doing all our analytics stuff happens fully in Kubernetes environments distributed across the whole planet. This is basically just a short history. And this short history is really, it is rather short because we're looking at a time frame of about like 6 to 7 years and an escalation of data that we've been moving around from a few gigabytes to today, like we don't even flinch when someone drops it to petabytes anymore. So we've seen a tremendous development there. And with Kubernetes, we finally arrived at the point that I would like, it's basically like a data center operating system for the future. It's not going to be the final step. I fully expect something new to come out in a few years. But right now it's the best we have, and it works pretty good in standardizing a lot of things that we've seen across different cloud infrastructures. My task in all this history was always to get things to run. And if you go far back enough, like there was a time before Docker, for those who don't remember, where we did deployments a little different. At that time, it really mattered to us, like whether we were deploying a monolith or like later on, like when the term became fancy, microservices. Or even like still today, use the old school SOA infrastructures, which still has some merit to exist on. In the end, all of this in the past few years has culminated in just container workloads. Even monoliths are something that can be stuck into a container and run on the infrastructure you like, which made things a lot easier, but also gave us a lot more new challenges, which are actually rather fun to solve. At Instana, we started tackling one side of the problem. Like the product Instana, if you don't know it, like we're an APM company. That means application performance monitoring. Like we specialized in figuring out what your infrastructure is doing. Be it like via the metrics, via spans, like figuring out like why a process gets stuck because like some backend database is stuck. So the problems our software solved are the problems of the growing complexity that we have there. And most of this complexity actually resides today in the container layer. At the same time, we at Instana had to solve a different problem. I mentioned that we're moving around tremendous amount of data. So the way to Kubernetes and running this infrastructure was not an easy one. And growing it into the clouds that we have today was a task that has stretched on for many, many years. The biggest advantage that we have at Instana is we have our Valiant Knights of SRE, a group of men and women taking care of our infrastructure day and night, running it as hot as possible so we save the most money that we can and that we don't upset our customers with downtimes. This group of people also has worked through a lot of iterations over the years with, like, for us, really starting things with Docker. And as I mentioned before, first with Nomad, and as we realized we're hitting the limits of Nomad, and also that we wanted to start thinking about distributing things to customers in their own data centers, more into the direction of Kubernetes. So that was our plan. And this plan was started with a product that we called SelfHosted. So SelfHosted Instana is what a customer will put into their own data center. Now, this went through a painful history, and I'll just recap this for shortly, because as much as we like containers today, there was a time that customers would just simply shoo you out of the house if you just mentioned Docker or any other of these fancy technologies. That's why our SRE team has been forced to first deliver a full version with RPM and Debians. I just mentioned this because, like, we all went through a painful past, and I don't want to forget about these pains. So when we got on board, the first thing we had to go through was, like, to finally think about how we want to deliver to the customers in reality. And that meant we wanted to do the same or as close to the cloud as possible. That means, like, we needed some way to deliver containers to the customers. With containers, we also had to learn that, like, Instana has a quite tremendous amount of containers, which we still managed to somehow deploy to infrastructure there. If we go back, the first thing that we started actually to learn, like, how we can deploy things on a customer infrastructure was, first of all, it needed to be simple as possible and be runnable by a customer who doesn't really have a grip on, like, the databases we have and doesn't have a huge SRE team. And that was the first iteration we went through. And just to highlight, like, the complexity and the things that we had to learn along the way, else that, like, this is like the component list that at that time we had to run. This list has in the meantime grown quite a bit. Additionally, this is the databases that we had run. Like, at that time, there was 6 databases. We're now deploying the 7th database we need for our analytics backend. Well, this solution worked for quite a while, and we knew for the next step to come. We used this time to basically learn how Instana was behaving, what we had to think about, and we had to drag knowledge out of the brains of SREs to come to a solution that would automate going to bigger infrastructures, because that was the next step. This, what you see there, we deployed on humongous machines, like machines with several terabytes of RAM, with 64 CPUs. Customers had to really provide huge machines to even be able to run Instana. But with our success, the infrastructures customer wanted to monitor were increasing, like, they were growing a lot. I mean, like, we all know that today, many companies run in their 5 to 6, run hosts in the 5 to 6 digit numbers. So monitoring those, like, we couldn't get away with just giving them, like, things running on one machine. And this gave us only one option. We had to finally think about to go to Kubernetes. Kubernetes had been, at that time, like, we knew about this, that this would be eventually the target we would go move to. We did not expect to have to move that fast, because customers with such a high demand were something that shocked us, that they were really ready to tell us, yeah, like, we will run our own Kubernetes cluster to take care of the databases as long as you provide something that we can use to run Instana. And this basically means, like, what do the customers actually want to do? Like the requirements we had like was scalability, but the question is also like scalability where? And this is like where the surprise for us started. It's like that most customers who want to host their own Instana installation don't really host it in their own data centers. Most of them still rely on GKE, EKS, and AKS. Like those three are what we have been seen with most of our customers. Then we have really the hardcore customers who run their own Kubernetes clusters in their own networks with their own SRE teams. And we also have I don't want to go the worst, but like they're like the trickiest customers is those that are running air-gapped. And that's like the point where we realize that you have to provide a lot of logic that can be, that needs to be maintained. So we started working and checking out like how these infrastructures actually have to look. And our first tries weren't really pretty. So we tried out a lot of things and started learning how to actually structure things that needed to go to the customer. And we start like from the bottom. And right now, we start the journey that we took on to actually get to the operator that we have today. The first thing we had to learn is like that everything, whatever you start out with, depends on having well-behaved containers. The well-behaved containers, and we were pretty good, only like 90% good at the time that we started. So each container needs to be resilient. I mean, resilience has to be a topic for quite a while now in the IT world. The problem is it still hasn't manifested 100% with everyone. Like resilience means like our components have to deal with databases disappearing and reappearing. They have to deal with downstream services not being available. And this should in general be able to handle all kinds of delays happening while doing any kind of process. Health checks. Well, this is like an issue that can directly be combined with readiness checks. Like whatever you do in Kubernetes work, the first thing you learn is how do you actually build a meaningful health check and how to correctly use readiness checks. For those, like most people I see using readiness checks still use them as now my application is ready, but it's like probably like one of the most powerful features being able to temporarily drag away load from your individual components. Resource limits and resource requests. This was one of the biggest pain points we had because sometimes people just missed providing the correct limits or we messed them up, which often led to pods being killed without actually having the need to be killed or things bouncing around in the cluster without finding their actual home because of constantly being rescheduled. And the last one, like I've just mentioned, like we have around I think like we're closing in on 40 components, 7 databases. Configuration to even have the ability to debug a system like that needs to be explicit, and it needs to be one way. So no messing around with different ways of configuration, like providing some things via environment variables, providing from here and there. You need to have one way to get every configuration to your pods, so you know how and when things are going to be read and used, and how to debug and read things when you're looking for a problem in a customer you might not even have access to. And then, like the last one, this is a rather painful one because this is something that we've missed in some components: signal handlers. Don't forget that, like normally your components get some grace time to shut down, but only if you really react also to the signals being sent to you by Kubernetes. Everything else will result in a very unkind termination using kill 9, which can catch your service in a very, very bad situation, depending on what it's doing right now. So in general, think about Kubernetes as some kind of soccer player and your containers being soccer balls being kicked around the whole cluster. It normally doesn't happen that often, but you have to expect that anytime you do anything in there, your container gets kicked and thrown around. So this was like what's the first lesson that we had to learn for delivering containers. These containers need to be extremely well behaved because when things are deployed on the customer side, hunting around because a container does not follow these few simple rules can be a very frustrating experience in trying to nail down a problem there. The next thing for us then was, how are we actually going to deliver? I mean, like, yes, you know the end of the story because we're at the operator con, but still there was some thinking done ahead of time because building an operator is not the easiest thing to do, as was mentioned before. So what are the options that we went through? Well, the first one, yes, this was the first one just for us, like to play around and learn things. And we basically also like try to do these things out with customers. This is customized. If you don't know customized, it's very well suited for smaller deployments and integration with automation if you really don't need that much activity in your cluster. Customized works great for smaller deployments. It works, it is templating. They denied templating. I call this templating what they're doing. It's nice. It's a YAML inferno, but it handles secrets and everything. And if you have a well automated pipeline, it really helps a lot. And that's where we still use it for our stuff. Next thing was like we were considering Helm for a brief moment until, well, it became apparent that like, since we wanted to do everything like with zero downtime deployments and upgrades, we needed to do live migration of databases. We needed to do a lot of things, a lot of activity that meant like holding back on components, taking load off components while we were doing upgrades. So Helm solves, like in my personal opinion and my experience, it solves the classic problem of simply deploying a simple piece of infrastructure. It helps deploying a fleet of microservices and things like that. And that's where it really does a great job. That wasn't really helpful for us. What got pretty close to our solution, it's just like this weird symbol right here. Just Google for the Helm operator. The Helm operator solves probably 90 to 95% of problems people face when running Kubernetes, because when do you want to react? Like, what do you mostly want to do? You want to apply a config change, like you provide a new value in a config map, and your service should just be restored. One option is to teach your service how to react to a change, which I think is a bad practice. But like, since Kubernetes does not have the notion of a dependency between a config and a pod, what you need to do is just like restart the deployment. That's what this can do. Like, it's basically a nice configurable way that allows you to have sort of dependencies between the things in Kubernetes and react on them. This solves 90 to 95% of problems that I've seen with customers running their stuff in Kubernetes. But for us, well, this whole thinking is to basically place in like 2 or 3 days that we went through this whole thing. We ended up with the Operator SDK simply because we needed to be able to help customers not see downtimes for longer than a few seconds, to coordinate updates across all our data stores, support scaling and all of this. So the Operator SDK is the one thing that we picked, and then we moved forward with it. And now we're finally at like the topic of this con. And this is the operator, or basically like what the operator in its core is, and that's the K8s event loop. I think like it was briefly mentioned at the beginning. I mean, the operator itself is not something that is built into Kubernetes. It's a set of best practices, patterns, which are all tied around the Kubernetes event loop. Basically, like Kubernetes can emit events for any change to its resources. It will provide you with events about scheduling. And you can basically listen to anything that's going on in Kubernetes and react to this. This is the reconcile with messages. So each reconcile happens in this kind of loop. Additionally, the Operator SDK helps simplifying things like defining your custom resource definitions and all these kind of things that you then need that form the whole package of what we call an operator. So the operator itself is a very active component that is brought into your Kubernetes cluster as a deployment. This deployment then can listen to any type of events that you define, and you can start reacting to these kind of events. In our case, and that's like the next step is we need to react to a lot of events and at the same time cause as little downtime for our customers as possible. And for us, like the tricky part was to figure something out that would help us to go through migrations and updates of the data stores and of our components. So the Operator SDK gave us the foundation for that. But that's it. Like, you get the events and then you need to start reacting on them. Since we have very long running operation and since we don't want to repeat operations, we had to come up with a concept to handle things so even like the restart of an operator doesn't cause an additional waiting time for us. And that's why we went to a concept that like many of you probably haven't heard since studying, which is finite state machines. So our operator, so what we implemented on top of the operator SDK is basically that anything that we do with with our different components is handled by finite state machines. So we start an operation. This operation can take up to several hours until things are complete, depending on the size of the infrastructure customer has. So everything we do, we track using a finite state machine. The important part for that is that a finite state machine is persistent. So like whenever like you kick the operator and the operator comes back online, you can resume wherever it was currently working on. In our case, we picked to persist everything that we were doing around the operator inside config maps. Config maps are a pretty good thing for that. You could, like, if you need to hide this information, you could also use a secret for that. It works both. But the primary thing for us was we did not want to also like ship a data store to persist anything that the operator is doing inside, because that would just add additional complexity on top. And since we wanted to have everything embedded in Kubernetes and not rely on any outside storage for what we're doing, we're now persisting everything we're doing into config maps. And that's also what I highly recommend. Try to stick as close to Kubernetes as long as you can. We might run in the future in the situation where we have to store additional state in a dedicated database, but that would mean volume management. That would mean additional requirements for actually scheduling the operator. So that's just going to make things more complicated. So what happens with the operators, whenever the operator is kicked, it will repeat the last transition, like these small errors. That means our transitions have to be idempotent. And our transitions are very aggressive in reporting if they encounter a state they haven't seen before. So if the operator was off for, like, let's say longer than 2 or 3 minutes, it will resume the full finite state machine, which makes things even more tricky because we have to make really sure that everything we do is fully idempotent and that we don't destroy anything that we've done before. This is basically where most of the thinking currently goes into what we built there. So in the end, we still ended up with a lot of things that we needed to do with Kubernetes, which we did not want to expose to the customer. The customer should have like the most seamless of experiences working with this whole operator. So let's look like the things that we actually use from Kubernetes. So like the most obvious thing that we are needing the customer to do is like actually create an operator deployment. So the operator needs to deploy somewhere in the cluster where it is running, where it gets resources and can start working. The next thing was CRDs, custom resource definitions. We currently just have 2 of those to minimize like exposure to the customer. CRDs are our core mechanism to control configuration of different parts of Instana, about interacting actually with all the installed components. At no time does a customer or anybody else have to interact with components directly. Everything goes through CRDs. This also requires some secret management, as always, but that's like the easiest part. More interesting is just like how you coordinate like actions like upgrades, updates, or like restarting certain components, rescaling, and things like that. For that, we basically went the route of using custom annotations. So whatever we need to do on the cluster that the operator does not catch itself is covered by providing a set of annotations. And then like, yeah, I know the status is part of a CRD. I just mentioned this specifically because the status for us is like the key thing to determine like what we need to do or like what like is actually going on in the cluster right now. The status itself is living. Like if you check out, like if you check any resource that you get from Kubernetes, there's always a status in there. It basically allows you to have like you can have a deeply nested JSON or YAML object in there that helps to expose like the information you need about the current workings of the cluster. And this also results in a whole hell lot of YAML. YAML is not really the nicest framework. As much as I like Kubernetes, as much as the same idea despise YAML, I'm from the XML world. I still would like to have that back, but like still, like I can't pick and choose here. But we did not want to expose the customers to that, especially since we anticipated that customers will have trouble with that. And that's where we went a different route for now. We basically built our own kubectl plugin. Everybody who knows kubectl has a great SDK for building your own plugins, mixes well with all kind of workflows that we're seeing with people using Kubernetes right now. So we built a kubectl Instana plugin, which allows to coordinate everything that we do in there, just like by knowing the annotation, querying the status, querying the CRDs, updating secrets, or managing like the operator deployment. So that's all hidden away in the kubectl plugin. It makes handling a lot nicer, since the only thing you now have to do is have a small settings file that will describe what we want to deploy in the cluster. An important side note, that, because I've seen this quite a few times, is that people expose additional services from the operator in forms of APIs. So far, we don't want to do this, because that would just circumvent the actual RBAC and everything else security-wise you have in Kubernetes, or you have to really make sure how you integrate this. So far, even if it feels sometimes a little wonky, we still do everything with annotations and CRDs, for the simple reason, this is the Kubernetes native way, and it can be secured a lot easier than just exposing an additional HTTP API. If you feel pressed to do this, always ask yourself, do I really need to expose this? We've often been tempted, we always decided against it. And so far, we're pretty happy that the only thing we have to use are really Kubernetes native constructs to interact with everything. So, I'm closing in on the 30-minute mark, and I have so many more slides. So I'll just run through the last ones. Testing. Well, for us, unit tests, that's a given. Integration tests, if you work like we do with many different databases and have to coordinate things, I highly recommend taking a look at test containers. We use it for both our Java code and the Go code. There's a Golang integration for that. So this is a pretty powerful tool to help you across the pain of testing your stuff. Infrastructure tests. So this is like the meaty part for us. Because we do ship this to customers, we have to test across a lot of different distributions, be it like container-wise, be it Kubernetes-wise. So right now we have a full pipeline running Terraform in GCP, bringing up all our databases, bringing up Kubernetes, using the kubectl Instana plugin to then deploy everything and then have our regression load and acceptance test running on this. This is brutal. It takes a lot of money, but like, since customers are willing to pay us for all this stuff, it still is quite worth the effort that we're putting into these. The last thing that we're currently working on are K8s tests. That means like heavy integration tests inside Kubernetes using kind. So this is like the next part of the pipeline that we're building to do all the behavior checks, like around scaling and everything. This is a really interesting topic, but like this is probably something for our next year talk at Operator Conf. And now I'm running to the points, like, because I still want to mention a few of the pain points we run in. When running a customer infrastructure, IOPS is a huge pain point because it's so hard to measure and you can never be sure that you're actually getting what the customer is promising you. No dependency in K8s. I mentioned the Helm K8s operator. This solves this issue partly, but it would be really nice to just be able to define like a relationship between a deployment and a config map and just have the deployment do its restart at the moment when the config map changes. Ingress in SelfHosted is a whole separate story of pain because it's very inconsistent, and even Ingress itself lacks a few things like being able to attach a static IP address directly to an Ingress. I know it can grab static IP address, but I need to be able to define them actually. So this was a rather painful thing to realize when we were going to customer infrastructures coming from Google, because in GCP, it is absolutely possible to have an Ingress with a static IP address predefined. And then, to out myself, I'm a JVM person. I've been doing Scala, Java, and all that for years, but like we had to realize that like the only real option for running in or building an operator is using the operator SDK, which is made in Golang. It was definitely worth the effort. We had to migrate a whole team of Java developers to Go, but like we had the ability to go to compare the results because we also have another operator built in Java. It was so much easier with the operator SDK and just using what the whole Kubernetes worlds provide. And the Kubernetes world is a Go world. So for us, it was a pragmatic choice. I won't fall in love with Go, but I love what we created with it. So it's a small price to pay. And then a final kudos, if you build operators or anything with Kubernetes, try out telepresence. It's an open source tool that allows you to work locally in a remote Kubernetes cluster. This has saved us so much time during the time where we were exploring, investigating, and just starting to get to know our way around in Kubernetes. So 31 minutes. I don't know how the Q&A is handled. Is there some moderation, or how you're doing this?
I can read it out for you. So far, we have just reached one question in the Q&A chat, but maybe they're coming up some more now. So first of all, thank you for this deep dive and this informative session. And you are forgiven for messing up the title.
Thank you.
Okay, so I'm going to read out the first question, or the only question that we have. Signal handler sounds interesting. Can you provide more examples?
Well, the basic thing is an operating system or any service is normally asking us, everybody, if you probably knows the kill command on Linux or in the shell. The kill command is used to send an arbitrary set of signals to a running process. Docker Kubernetes sent the kill 3, I think, to the service, which announces, hey, please shut down. Now you have to, in many systems, handle this gracefully by already having default signal handlers, which will just catch the signal and oh yeah, I'm supposed to shut down and start shutting down things. If you don't do this, you will get some grace time by the runtime. So the runtime, be it containerd runs or anything, will then wait for a while. And if you're not shut down in that time, it will send a kill 9. The kill 9 is basically a kernel level event that will just rip away CPU memory and everything else and kill your process instantly. This can, if you have data in flight, or you need to shut down, or you have open transactions or anything, this would just mean that that data collapses and you can end up in a rather wonky state. This gets even worse, if you have databases running. And you could, first of all, always remember to have specify a correct amount of grace time for your database to shut down, but also actually react on it, or define something that catches the signal and reacts properly, so your database won't be kill 9. And a kill 9 on the database is even worse than a kill 9 on a service. So that's basically it.
Thank you. And there just came up another question. So is there any risk of race conditions with using config maps for your operator state machines?
You have to think about these, yes, but the first thing, for now, our operator is, first of all, is not running in parallel mode. There's 2 modes an operator can run in. You can have it work with just one event at a time. That's what we use right now for most of the things, because we're fast enough to stay in that. Things get tricky when you allow more than one interaction at a time. What we do then is mostly that we check that, first of all, it really depends on how you run your operators. If you're running them in a fleet, then yes, you have to think about who's the leader right now, but leader election should take care of that. And then we normally isolate by unique names for the config maps. And a running state map has, a running state machine never is meant to have more than one operator running on it. And that's how we isolate. But you're right, race condition could be something that you happen if you're not really careful. We'll try to avoid that, but there's no guarantee that we will never run into one.
Okay, and another one just came up. Did you consider projects like Cluster API or Kubernetes for replacing the Terraform part?
Not right now. We also use Pulumi in some other projects. The thing is with Terraform is it has developed into some sort of lingua franca across bringing up cloud infrastructures. Most people I know, and even people we hire, know Terraform well enough, and we haven't yet hit the limits of Terraform that we consider ditching it. I know that there are other options out there, but so far we are really happy with it. And it is the most common thing with having dedicated support from GCP, and Azure and all of these. So for now, we're not considering, we're using other options like Pulumi, but we're not considering to switch right now. It might come up. It always depends on the developers currently handling this.
Okay, thank you. Well, there are no more questions in the chat. So I guess that's it for now. Thank you very much, really, for being our speaker for today at OperatorCon. If there are still some questions, yeah, you can reach out to Jochen Mader. You can see his Twitter handle, and you also can reach out to marketing@kubernetes.com. But I just see that there is, yeah, now there is another question. Any examples for telepresence?
Well, not really example, just go to the page, like you can install it using Brew. And what it does, it basically opens a local proxy that also forwards the DNS queries to the Kubernetes DNS queries. So just try it out. You just need like a correctly configured Kubernetes environment that you can connect to. You install it, you launch the telepresence in Bash and or in whatever shell you want to. And the shell you then have is basically resolving anything against the Kubernetes cluster. So like just go to their page, yeah, no, like it's here in this, it's in the slides, a little bit back. Just go to this page, telepresence.io. On Mac, you can install it via Brew and just download it and start playing with it. Works also like with local Kubernetes cluster like Kine and all this.
Good. And one more. This is not gonna end. Are there any best practices for designing your CRDs?
Oh, not really. Like CRDs, like it's what they are, custom resource definitions. You should really take care of defining them as a correctly REST API, because like that's how you're going to interact with it. Beyond that, I mean, like it's type safe what you're doing there. You can have additional validations on top of that. Like you can go pretty wide, and I would not recommend to go do wide, but I won't give out any best practices because this is highly dependent on the application you want to deploy. For us, the main thing was like the CIDs are our entry point and are like the binding thing also like for resources, because like CRDs is also, yeah, this goes into garbage collection units, but you have to normally also as the root of everything you're doing there. So designing them, it depends on your application, really. Like I have a hard time giving you any guidelines there. Like it's really like what you need to do in there. That's why like Kubernetes allows you to do it like that. So just make sure that it's definitely REST enabled and that you probably take the time and provide a dedicated Golang client in it. Like there's a lot of tutorials around that you should definitely do. But beyond that, you can go pretty wide with them.
Good.